then we will get started. All right, so today, solving systems of equations using elimination. And it's called elimination for a very good reason. In order to solve the system, we're going to start by eliminating one of the variables. And you'll see how we do that in a moment. All right. So I list this as a 5-step process. It really normally doesn't take all 5 steps. But we want to write the system so the terms are lined up. In other words, we have our x's over our x's, our y's over our y's, our constants over our constants. The object, we want to get either the x or the y coefficients, the number in front, to be exactly opposites, so that when we add them together, we get 0. We eliminate that variable. That's why it's called the elimination method. In order to do this, it's possible that we might have to multiply one or both of our equations by a constant, by a value, so that our coefficients are opposites. Step 3, we're going to just add the equations together. We'll be left with one variable. And it's actually pretty nice with this method because we'll have a variable with a coefficient is equal to a number. And then we just solve for that variable. Almost always, the only step in solving is dividing by whatever number is in front of our variable, by the coefficient. Once we have the value for one variable, just like with the substitution method, we take that value, plug it in for the variable in one of the original equations, and solve for the other variable. And then if you have the packet, there is a typo. It should be write the answers from step 3 and 4 as an ordered pair x, y, and check your solution. So again, I think one of the most powerful pieces of solving systems is the fact that when we're done, we can know whether we're right or not simply by checking our solutions. Excuse me. All right, so here we go. Solving a system of equations using elimination. Solve the system. So we have 2x minus 4y equals 2, and negative x, or the opposite of x, plus 4y equals 3. In this case, you'll notice the y's have opposite coefficients. So that takes care of step 1 and step 2. So at this point, we can add these equations together. So 2x plus negative x leaves us with 1x. Negative 4y plus 4y, that's 0. 2 plus 3 is 5. And, I have the 1 there. We really don't need to divide by 1, but I will show that. So our x value is 5. The next step is taking that value of 5 and plugging into one of our 2 original equations. It doesn't matter which one you choose. I'll choose the second one um, because it has that positive 4y. That's the only reason I'm choosing it. So we get the opposite of whatever x is, plus 4y equals 3. And now we're going to solve for y. Add 5 to both sides to undo that minus 5. Divide both sides by 4 to undo the multiplying by 4. So we have a solution 5, 2, and we can check that. And because I used the second equation to figure out my y value, I'm going to check it with the first equation. So 2 times 5 minus 4 times 2, is that equal to 2? And if I simplify, I get 10 minus 8 is equal to 2. 2 equals 2, which is true. That is a good solution. Next example. All right, next example. 3x plus 4y equals negative 8. 3x minus 3y equals 27. Notice here we do not have opposites. However, we have the exact same coefficient with our x's. So when that happens, what we can do is multiply one of our equations by negative 1. So, and it doesn't matter which one you choose. I'm going to choose the bottom one. I'm going to multiply everything by negative 1. So 3x plus 4y equals negative 8. When I multiply by negative 1, I get negative 3x. Instead of minus 3y, that changes to plus 3y. And negative 27. Add those together now, because now my x's are opposites. So 3x plus negative 3x, that's 0. 4y plus 3y, 7y. Negative 8 plus negative 27 is negative 35. Divide both sides by 7. And we get y equals negative 5. We can plug that value in to either equation and solve for x. Again, I'm going to use the original equation, but I'm going to use the second one here. Three x minus 3 times my y value, which is negative 5, equals 27. Three x. I have a minus 3 times a minus 5 gives me a plus 15. Subtract 15 from both sides of the equation. Three x equals 12. So x equals 4. So my solution appears that it's going to be 4, -5. Now I want to check to make sure that's true. So I go back. I've already used that second equation, so now I'm going to use the first one. 3 times 4 plus 4 times -5. Does that equal -8? 3 times 4 is 12. 4 times 5 times -5 is -20. Does that equal -8? And we get -8 equals -8, meaning our solution is true. All right, next example. (3x plus 22y equals 39). 5x plus 11y equals -12. Now in this case, I don't have coefficients that are exactly opposites, so I can't just add from where I am. I don't have coefficients that are exactly the same, so I can't multiply one by a negative -1 and then add. So my third option would now be, if you remember from our steps, our second step says you may need to multiply one or both equations by a constant. And if I look, the 22y and the 11y, well, 22 is simply 2 times 11. So if I multiply my second equation by -2, I will get opposites that I can then add and eliminate, in this case, the y's. So the top equation stays the same. The bottom equation, I take -2 times each piece. So -2 times 5x is -10x. -2 times 11y, -22y. -2 times -12 is +24. And now I've got my opposites for my y's, so I can add. 3x minus 10x is a -7x. 22y plus -22y, that's 0. It eliminates the y's. 39 plus 24 is 63. And then divide by -7, our coefficient of x. We get x equals -9. Once we have that x value, we can plug into one of our two equations and solve for y. So, and again, it doesn't matter which one you choose. Maybe for this one, I'll try the top equation. 3 times -9 plus 22y equals 39. So negative 27 plus 22y equals 39. I'm going to add 27 to both sides. (22y). See, 39 and 27 is 66. Divide both sides by 22. Y equals 3. So again, it looks like my solution is negative 9, 3. And I say it looks like because we do want to double check that. And so I used the top equation, the first equation, to get my y value. So I'll use my second equation now to double check my solution. 5 times negative 9 plus 11 times 3, is that equal to negative 12? 5 times negative 9 is negative 45. 3 times 11 is 33. Is that equal to negative 12? Indeed, it is. So that's good. We get that as a solution. All right. So we've had one example where we already had opposite coefficients. We had one example where we had the same coefficients. We had an example where we had to multiply by a negative number to get opposite coefficients. And now we have this third example. Again, I don't have coefficients that are exactly opposites. I don't have coefficients that are exactly the same. I do notice that my x's have opposite signs and my y's have opposite signs. So you could approach this two different ways. One way would be to try to get the x's to be exactly opposites. Unfortunately, I can't multiply just one equation to get opposites. I would have to multiply both. It's a little more work. I do have y's that have opposite signs, and if I multiply my first equation by 3, I will get my opposite coefficients for my y's. So there is a process, a thought process going through to kind of make that determination on what you should do. Multiply everything by 3. So I get minus 15x minus 6y equals 4. And the second equation, I just leave the same. And then I'm going to add. So negative 15x plus 3x, that's negative 12x. Minus 6y plus 6y is 0, that's eliminated. Oh boy, Mr. Gingrich made a mistake. I need to make sure I multiply everything by that 3. I didn't multiply the 4 by 3, and I should have. So I should have had equals 12 there instead of equals 4. Someone probably already caught that. If you do catch that, just shout it out or send me a message in the chat so that I don't continue to work and get the problem wrong. Then I'm going to divide by negative 12. And if you divide this by negative 12 and reduce, this reduces into negative 3 over 2 or negative 1.5. And I'll be honest, this is one of the few cases where I think using a decimal number is easier than using a fraction. They are the same, they mean the same thing, but when we plug in and solve, it's just a little bit easier, I think, to have that decimal value. So now I'm going to plug that negative 1.5 into one of my two equations. I don't know, I think I'm going to use the top equation. So I have negative 5 times negative 1.5 minus 2 times y equals 4. This is positive 7.5 when I take 5 times a negative 5 times negative 1.5. Subtract the 7.5 from both sides. And divide by negative 2. Uh, 1.75, excuse me. If you wanted that as a fraction, it would be positive 7/4. So my solution looks like it's going to be negative 1.5 and positive 1.75. Again, if you want it as a fraction, negative 3/2 and positive 7/4. We should check. Again, these are the exact same. And because we used the first equation already to find our y value, we're going to use our second equation. So 3 times negative 1.5 plus 6 times 1.75. Is that equal to 6? Let's see. Negative 4.5 plus 10.5. And again, don't be afraid to use a calculator if you need to. It's okay. There's absolutely nothing wrong with using a calculator. I get 6 equals 6. Either equation would be correct. You don't have to find both. Either ordered pair, I should say, would be a correct answer. You need either one or the other. All right. So what I'm going to do is I'm going to give you a minute or 3, maybe 4, to go ahead and try these two examples. Again, what I would ask is when you get your solution, go ahead and put it in the chat. So for instance, if you solve the first one and you get 0, 0 as your solution, just go into the chat and type 0, 0. 0, 0 is not the solution, but that's just an example. And then do the same thing for the second system there. So I'm going to give you some time. And then I will mute myself and turn my video off so you don't have to look at me as you're working on your problem. If you have a question, again, go to the chat and we can try to work through that. If it's something we can't chat through, what I'll do is I'll just set up a breakout room for you and then we can go in and talk about it. All right, so 4 minutes, and I will see you back here in 4 minutes. All right. So, excuse me. There we go. Let me just give you the solutions. If you would like to see how I got those solutions, just let me know in the chat. I'd be more than happy to go through the problem. I'm going to write it over here. This is 2, -1. The second one is -3, -5. So if you want to see number 1, just go in the chat and say, something, can we see number 1? If you'd like to see number 2, then in the chat type in, can we do number 2, or something to let me know which one you would like to see worked out. All right, so we've got actually requests for both. That's fine. We'll do both. Yeah, all right. So for the first one, our 2's are exact, our x coefficients are exactly opposites. So I don't have to do anything. I can just add right away, because 2x plus -2x is 0. The x's are eliminated. 3y plus 2y is 5y. 1 plus -6 is -5. Divide both sides by 5. We get y equals -1. If I, excuse me, if I plug that value in to one of my two equations, maybe I'll choose the top equation. So 2x plus 3 times -1 is equal to +1. This would be the same as 2x minus 3. Add 3 to both sides. Divide by 2. We get x equals 2. Now I'm going to check my solution by plugging into the second equation. -2 times 2 plus 2 times -1, is that equal to -6? So -4 minus 2 or plus -2, either way. And -6 equals -6, it checks out. All right. For number 2, I don't have coefficients that are exactly the same or exactly opposite. So now I need to decide, can I multiply? And one of the things I will always do, I always check the smaller coefficient. So can I multiply 3 by a constant to make it -10? And I could, but it would be a fraction and it could make the problem really messy. So then I look at my y coefficients. Can I multiply 4 by something to make it equal to 12? That I can do. I can multiply that by 3. So I'm going to rewrite these underneath. So I'd have 9x plus 12y equals -87. Again, you may want to use a calculator if you need to multiply that out, just to make sure you got it. The second equation just stays exactly the same. And now we add. 9x plus 10x is 19x. 12y minus 12y, they are eliminated. That's 0. Negative 87 plus 30 is negative 57. Divide both sides by 19. You get x equals negative 3. Choosing an equation to plug into to find my y value. Again, it really doesn't matter which one you choose. I'm going to choose the second equation this time. I think other times I've chosen the first equation. And one of the reasons I'm going to choose the second equation, it does have bigger coefficients. But then when I check my overall solution, I can use the smaller coefficients for my final check. You don't have to do it that way. You can use whichever equation you want. So this one, we want to be a little bit careful with. We get negative 30 minus 12y equals 30. We're going to add 30 to both sides. So negative 12y equals 60. Divide by negative 12. Y equals negative 5. So negative 3, negative 5 appears to be our solution. And we can check. And now I'll use that top equation for my check. So 3 times negative 3 plus 4 times negative 5. Is that equal to negative 29? Negative 9 plus negative 20 or negative 9 minus 20, either way. And we get negative 29 equals negative 29. That is a good solution. All right. Hopefully that helped out. For those of you that asked for it, and even if you didn't, hopefully it just reinforced what you did. So let's move to the next example. So this example is actually exactly the same as what we did with our previous examples. The only difference here is what happens when we solve. So just like solving with substitution or solving with graphing, we could get infinitely many solutions. We could get no solution. So as I look, there is no coefficients that are exactly the same. I do not have coefficients that are exactly opposites for this one. However, if I look at the 6, I can multiply that by negative 2 to make it the opposite of 12. So I would multiply by negative 2 on my top equation. Negative 12x minus 8y or plus negative 8y, either way, equals negative 4. 12x plus 8y equals positive 4. Add. Negative 12x plus 12x, that's 0. Negative 8y plus 8y, that's also 0. So I have 0 on my left-hand side. Negative 4 plus 4 is 0. So I have a case 0 equals 0, a number equals itself. This is our infinitely many solutions. That's one way you can write it. So with solving by elimination, the only way you're going to get infinitely many solutions is you'll have 0 equals 0. It has to be that way with solving with elimination. With substitution, it could be 2 equals 2 or 5 equals 5 or -7 equals -7. It could be any number equal to itself. With elimination, it has to be 0 equals 0. All right. And again, a little bit faster if you get infinitely many solutions than actually finding the solutions if there's an X and a Y value that work. Example B, -2x plus 3y equals 3, and 6x minus 9y equals 7. Again, I do not have exactly opposites. I do not have coefficients that are exactly the same. So now I look at my x's. Can I multiply -2 by something to get it to be the opposite of 6? And the answer is, of course, Mr. Gingrich. You could multiply that by 3. So we would get -6x plus 9y equals 9, and 6x minus 9y equals 7. Add those together. -6x plus 6x, 0. 9y plus -9y is also 0. 9 plus 7 is 16. Here we have something that's not true, so our system has no solution. And again, with elimination, it will always be 0 equals something that's not 0 in order to get that no solution for an answer. All right. So we've had a couple different examples. We've had an example where we already had opposites, so we could just add and find the solution. We had an example where we had coefficients that were exactly the same, so we had to multiply by -1 and then add. We had an example where we could multiply one equation by a constant and get opposites and go and solve that equation. Now we have a situation where we're going to have to multiply both equations. So this is the most work that you'll have, but very solvable. So if we look, we've got -6x plus 7y equals 11, and 8x plus minus 3y equals 17. We don't have coefficients that are exactly the same. We don't have coefficients that are exactly opposite. I can't multiply 6 by an integer and get the opposite of 8. I can't multiply 3 by an integer and get the opposite of 7. So now what I would do is multiply both. And there are a couple of ways that you could that you can do this. One easy way is I look for the smallest coefficient. And in that case, the smallest coefficient is this 3. So what I'm going to do is I'm going to multiply the first equation by 3. And then because the signs are opposite for my y's, I'm going to multiply the second equation by 7. So I'm just multiplying by the, because they're opposites already, just by the positive coefficient in the opposite equation. So again, we want to be very careful when we do this. Negative 18x plus 21y equals 33. 56x minus 21y equals 119. And again, that's one I would recommend. If you're not sure, go ahead and check it with the calculator. Again, that's what the calculator is there for. We're going to add negative 16x. Oh, thank you. Yeah, see, someone's on top of it. I think I said negative 18, but I wrote negative 16. Negative 18x. And if I take negative 18x plus 56x, I believe I get 38x. 21y minus 21y is 0. And this is 152. This is a problem when I did it with third hour yesterday. I messed it up. So, and I didn't realize it until I went and checked my solution. So another good reason to check your solutions. Divide both sides by 38. And I think x equals 4. Take that, plug it into one of your original two equations. So if I choose the first one, negative 6 times 4 is negative 24, plus 7y equals 11. Now I'm going to add the 24 to both sides. 7y equals 35. Divide by 7. We get y equals 5. So we have our solution. And I'll use the second equation to check my solution. Try that again. 8 times 4 minus 3 times 5. Is that equal to 17? 32 minus 15. Is that equal to 17? And it is. So one of the things when you have to multiply both equations, you'll notice we get larger numbers, larger values that we have to work with. Take your time. It's not a race. And just be very careful as you're working with those values. Here we have 4x minus 7y equals negative 24. 5x minus 10y equals negative 30. So again, looking at my coefficients, the 4x, is there anything I can multiply that by to get negative 5? Well, a fraction, which isn't the best way to go. And then with the negative 7y, is there something I can multiply that by to get negative 10? I'm sorry, to get positive 10. Again, yes, but it would be a fraction. So what I would do is, it looks like my smaller coefficients this time are with my x's. So I'm going to multiply the top equation by 5 and the bottom equation by -4. You could also say, well, I want to multiply the top one by -5 and the bottom one by +4. It's okay, as long as one of them, in this case, is positive and the other is negative. So when we multiply, our x's are exactly the opposite. So if I multiply everything by 5, I get 20x minus 20x minus 35y, excuse me, equals -120. And in this case, 20x plus 40y equals 120. Add. Forgot my x again. There we go. 20x plus 20x is 40x. Whoa, wait a minute. Let's try that again. This should be negative 20x. Now let's add. So 20x and negative 20x is 0. Negative 35y and 40y are 5y. Negative 120 plus 120 is 0. Divide by 5. Y equals 0. Take one of my equations, excuse me, and plug 0 in for y. Again, I'm going to use the second equation. So we have 5x minus 10 times 0 equals negative 30. So 5x equals negative 30. Divide by 5. X equals negative 6. So my solution looks like negative 6, 0. And we'll check that with the first equation. 4 times negative 6 minus 7 times 0. Does that equal negative 24? Now 4 times negative 6 is negative 24. 7 times 0 is 0, so I'm not even going to worry about it. And the answer checks out. All right. So again, there are a couple of try nows. What I'm actually going to do is go to the next page and copy that one over here, so I can leave it on one page with a nice big font. And I'll give you a few minutes. Go ahead and work on these two. And then we'll take a look, if we need, at the solutions. Again, you can just type in your solution in the chat. That worked out pretty well. If you have a question, feel free to ask it in the chat. And we'll take a look at answers in about 5 minutes. All right. So our solutions, let's do it this way. I'm going to remove this. I'm going to remove this. And then we'll have the other side here in just a minute. So my solution for the first one -4, -1. So I know some of you just gave the X value in your chat when you shot the answer down. Make sure you have both the X and the Y. Do we need to take a look at that solution? Okay. Then number 2, this one was no solution. Do we need to take a look at that problem? All right. So what we will do is